As I think about my career in aviation, I'm absolutely convinced that there were two things that drove a whole generation of young children into aerospace and engineering. And those two things are the Jetsons, because, I mean, how cool is that to be flying around in your own little spacecraft? I know growing up, I certainly paid a lot of attention to the Jetsons. And the second thing, clearly, was when the man landed on the moon in 1964. I can remember like it was yesterday when my dad sat me down in front of one of those black and white televisions. You know, the console's like a piece of furniture, a lot of nods in the room. And he said, "Mo, this is very important. You need to stay up late tonight because a man is going to land on the moon and it's going to change everything." And I remember sitting there as close as I could to that television, just in awe. And at 10:17 p.m. Eastern Time, US, the man did land on the moon. The next week, my dad bought me a moon globe. Now, there's not much happening on a moon globe, but I knew exactly where the Sea of Tranquility was. And I looked up at that moon every night like so many children across the globe and said, "I want to be an astronaut," or "I want to fly." And that's what got us into STEM and has given us a really great career. So today, I'm going to talk about the future of flight, bring you through some history, but the main thing I want you to think about is exactly what James just talked about. Aviation is a high technology industry, but innovations happen incrementally over time. And there's a lot of experimentation. Some things work, some things really don't work. But we're always learning over and over and how to build on that learning. And that's the process that I think people sometimes forget about when they think about innovation. So I'm going to start with something that a couple of charts that where you look at these airplanes and you say, wow, look at those. And you don't exactly see them flying around in the world today. But I'm starting with them because sometimes when you develop an airplane or another vehicle, the technology just couldn't meet the requirements of a customer at the time. So if you look at the airplane on the top, you see a Convair Pogo, and it literally looked like a pogo stick. The aircraft took off vertically, transitioned to horizontal flight, and then obviously landed vertically. At the time, couldn't meet the Navy's requirements, and so that was put on the side. The second one I point out there is the one you can see called the short Mayo composite. And it's actually two airplanes, one on top of the other, a seaplane and a flying boat. And the idea was that combination of aircraft could take off, fly across the Atlantic, about midway, do a very complicated maneuver. The smaller plane on top would go to its destination, and the lower plane would turn around and go back to base. And there was one of those built, a lot of experimentation, and we learned a lot from that. If you look at today, for the Pogo, there is now a rotorcraft called the V-22, which actually does take off vertically, transitions to horizontal flight, and lands vertically. If you look at that short Mayo composite, think about the first time you saw a 747 airplane with a space shuttle on top. And so my point is, at the time, you may not have thought of those programs as successes. But over time, we learned a lot from working on those projects, as did the rest of the aerospace business. And it can be applied to the next things we work on. Now, one of the things early on in aviation was how do we go from a flight, the first flight with Orville and Wilbur Wright, which was about 20 seconds, about 48 kilometers per hour in the first flight. And the customers and passengers wanted to fly across different continents, across the world. But in order to do that, there were many, many stops. You can see, a little difficult, but the purple, you can see it took 32 stops to go from Sydney to London on a flying boat. It took 10 days to do that. And so you can see that was quite a journey. In 2005, a 777 airplane went from London to Sydney in 19 and a half hours nonstop with 240 passengers. So direct point-to-point is something that over the course of time We have been able to develop new aircraft design, new engine design, different ways of doing air traffic management, and as it says, pulling out all the stops, because that is what the customer wanted. And there was a lot of technology that went on behind the scenes to do that, as it does today. The next thing I wanted to mention is that technological innovation does demand a significant investment in research and development in the aerospace business. We saw in Mark's presentation the investment that General Electric is making, Boeing making investments of $3.5 billion per annum to continue growing and pushing technology where we want it to go. But money is not the only thing, and I think that's been a theme in this conference today. A lot of it depends on the mindset of the leaders, the environment that we create. Do we allow our engineers to be curious, which is what got them into engineering in the first place? Do we allow them to be creative and to try things that don't exactly look like they're going to work first time around? And do we allow them to be, frankly, courageous to try some of these wild ideas so that we can actually advance the system? Boeing has opened 6 Boeing Research and Technology centers in the world. One of them, and the largest international center, is here in Australia. A team in both Melbourne and Brisbane working on new technologies here, and really a leader in our resin and fusion composite work. In fact, the trailing edges of the wings of the 787 Dreamliner were developed here in Australia, and it is the only place in the world that we build those parts. Real leaders in technology. In addition, working robotics, working air traffic management, and working with a number of our partners, which is key. We don't corner the market, not any one of our organizations do. And we've found over time that partnerships are really powerful. And so here in Australia, we have very close partnerships with CSIRO over the last 25 years, DSTO, which is the Defense Science Technology Organization, research partnerships with universities from Queensland to Victoria, and suppliers throughout Australia from New South Wales to Perth. And those technology organizations and suppliers work with us and the global supply chain to continue to advance aviation. Okay, here's another idea, sonic cruiser. Back in the 1990s, after we got working on the distance, we moved more to how do we get from point to point much faster. Most of us as business travelers would love to be where we need to go much, much quicker and do it point to point. A lot of work went into the sonic cruiser to design an airplane that could do just that. It was to fly at 0.98 Mach and shave several hours off of any given long-haul flight. We learned a lot about that. But then oil prices spiked. Eventually 9/11 occurred. And the airline industry in a whole said, hey, we'd really love that. We're really excited about that. But what we really need is fuel efficiency. And then we stopped working the sonic cruiser and focused our attention in the aerospace business on how to be more and more fuel efficient. And so that has been a real focus. Now, was that a waste to work on the sonic cruiser? Well, absolutely not. Much like the Pogo I talked about before and the other airplanes, the sonic cruiser helped us learn a lot about lightweight composites, a lot about engine technology, and a lot of the things that we use now in the 787 Dreamliner. So we went from what was clearly going to be a game changer to a different kind of game changer, an airplane that was much more fuel efficient than airplanes before it. Dreamliner's around the 20% in improvement in fuel efficiency, and we used a lot of what we learned from the sonic cruiser to achieve that. In addition, there are incremental things that you learn along the way. You know, how do you lower the cabin altitude so there's more humidity and it's more comfortable? How do you work with light so that the passenger experience is much, much better? And a lot of those things you learn from some of the experiments that went well and some of them that really didn't work well at all at the time. So now there are over 1,000 787s ordered, over 200 flying in the world with 40 airlines. There's been over 25 million passengers on the 787. So was the Sonic Cruiser successful or not? And when you think about it from an innovation perspective, it was very successful because it enabled the future for us. And who knows, right? And we'll talk a little bit about what future airplanes might look like. So other ways of innovation are very incremental, and sometimes when you look at the airplane, you really can't tell. Although, I must tell you, I've been absolutely blown away by how much Australians know about airplanes. Really, it's phenomenal that they can tell you it's a 737 400 or, it's just amazing to me. But again, you're pioneers in traveling, and I think that's why. But there's been a lot of technology even in the 737. So that's the highest selling single aisle airplane in jet history, starting way back in the late 60s. And if you look at the airplane in the middle, that is actually the 737s that are flying around Australia today. Probably many of you have been on it. Very fuel efficient, great for point to point in Australia, and a lot of improvements over the initial 737. The one on the right is called the 737 MAX, and that will be flying in Australia in 2019. Great collaboration with GE to make the efficiency 8% greater for fuel efficiency than the original models, and clearly something that will continue the 737 line in the future. The point of this particular one is to just say that sometimes, we think in aviation the airplane has to look so much different in order to be innovative, and that's really not the case. There's a lot going on in there, and again, focused on the customer. What does the customer need at the time? And that's how we make the changes. If we go to the next, I'm just going to briefly touch on that. The 737 also morphed into military airplanes, so it's not only in the commercial arena or in the domain that you're focused on. There's also some adjacencies that you can work on. These two military derivatives, I actually worked on the one with the large radar on the top. It looks like a surfboard. We always thought that was appropriate for Australia. Very high-tech machine, lots of innovation inside in avionics in particular. And then the one that looks more like an airplane, but many antennas on it, is actually the P-8 Poseidon, which the Royal Australian Air Force will also take into service in a few years. Next one I want to mention, if you look to the future, Sugar Volt. So Sugar Volt is actually subsonic, ultra-green aircraft research. We do like our acronyms, but that is going to be a very sweet airplane in the future, a hybrid that is both electric and aviation fuel powered. And so there's a lot of research going on how we can continue to expand that capability. You can see that it talks about traditional fuel, greater wingspan, and open rotor engines. A lot of work going on in that arena. Also, collaborative work with the University of Queensland on scramjet technology. We've been working closely with them. Scramjet, think Mach 8.0, roughly 8,000 kilometers per hour. Very fast. That plane from Sydney to LA in an hour and a half or so would be really sweet. But we're looking at the 2030s to 50s, right? This is in the future. But a lot of good research going on to enable that in the future. And then finally, to close out and say, hey, some of us that were dying to get into space when we started our career still have a chance. A lot of exciting things going on in space travel. Most recently, this particular one, the Space Transportation Space Station. Boeing did win a bid on that, and I just wanted to let you know that there is one seat for a space tourist. Have my name on the list, and hopefully I'll be able to do that. The exciting thing is way out in the future. It's actually by 2017. The airplane will start making its travel. So a lot of exciting work going that. So I talked about the environment, and the future is going to be a combination of these things. But clearly, Boeing is a company at its core that always builds something better and takes technology from all over the world to try to continue to meet the customer's requirements. So our creative and curious and courageous engineers, both at Boeing and our suppliers, will be all over the future, and hopefully you'll enjoy the planes from here to then. Thank you.